We're going to be discussing coterminal angles, at least defining them, and also discussing how to find them using radian measurement. Okay, so we say that first of all, what are coterminal angles? We say, well, any two angles that have the same initial side, so they have to have the same initial side and the same terminal side, we say are coterminal. And recall that terminate or terminal, that is the side of an angle where it ends. So for instance, if I were to just randomly draw an angle over here, we could say that maybe I have two angles, and the first angle, its initial side, maybe it's in standard position, it leaves the positive x-axis and it goes over here. We say this is some angle theta, and then perhaps I have some other angle here. We could like flip into a different color. We could say maybe my other angle here, we could say this is some angle alpha. It's a negative angle. It also has the same initial side, but it also has the same terminal side. We say these two angles by definition are considered to be coterminal. So a lot of the time we are interested in finding coterminal angles, and the reason why really, to be honest with you, is because if I had a choice between, let's just say it, using theta up here or alpha up here to have a conversation about this situation, honestly they both describe the same situation, an angle that left the positive x-axis and landed at this spot. So I'm telling you, I would probably opt to deal with the theta, okay? And the reason why is only because it is positive. So if we're so interested in finding coterminal angles, then perhaps we need to discuss how is it that I could possibly find a coterminal angle given something, some angle to begin with. So I'm actually going to take a degrees approach to this just to begin with. We say 40 degrees. If I were to sketch a 40-degree angle, this would be just shy of, say, a 45, so that looks a little too 45-y to me. If I were to say I had an angle theta, and this angle theta is 40 degrees, and I wanted to find another angle that starts on the positive axis but lands in the same spot, we could say, well, we could take the 40 degrees and just add on another full spin to it, and then it would go around again. We could say, well, what angle would that be? Well, really, it would just be 40 degrees plus 360 degrees. We say 400 degrees, and it would be easy to see if we sketched a 400-degree angle, that would be one full rotation plus another 40. So these are indeed coterminal angles. The point I want to draw here is this. If you want to find coterminal angles, all we need to do is add on or subtract off multiples of full spins. Okay? The reason why I say that is because I want to do this not in degrees, but in radians. So I say, past this here, we say, for example, the angles 0 and 2 pi are coterminal. Recall that 0 degrees, if we were to sketch both of these out, we say 0, or at least 0 radians. 0 radians is a really easy angle to sketch. We say this is 0 radians right here. If I were to sketch 2 pi radians, recall that 2 pi radians is one full rotation, so that'd be a pi plus another pi. We would say that this is my 2 pi radian angle right there. So these are both coterminal. Also this we say pi sixth and 13 pi sixth, just to kind of illustrate this here. We'd say a sixth of pi. Recall that a sixth of pi would be a 30-degree angle. If we're doing this in degrees, it'd be, if we were to partition this top part into 6 total equal sized pieces, we'd say here's my pi sixth right here. What would 13 pi sixth look like? Well, 13 pi sixth would be 6 pi sixth. That's the same thing as pi. That'd be 6 pi 6, if you want to consider it that way. We say this is 12 pi 6 over here, but 13 pi 6 would be 6 pi 6 plus another 6 pi 6, which is 12 pi 6, plus one more pi 6 right there. So this would be my 13 pi 6 radian measurement, okay? And that would be coterminal again with this first angle that we saw here. Two coterminal angles, okay? So we say in the case of pi 6 that we just looked at here, we can say that it's coterminal to any angle that fits this form right here, pi 6 plus 2 pi n, where n is some whole number, some integer. And basically what this is saying is any multiple of 2 pi will coterminate. And the reason why is because it's the same thing we talked about over here when we added on 360. 2 pi is the same thing as 360 degrees, but in radians, okay? So what we're concerned with in this video is being able to find coterminal angles, but to do it in radians, okay? So basically, to find coterminal angles, we could say, I'll go ahead and write this out here. Let's see if I can get a bigger font size. I don't know. Try again. There we go. To find a coterminal angle to theta, take the original angle and add on or subtract off any multiple of 2 pi. Okay, and that's essentially what we do to find coterminal angles, especially in radians, of course. Okay, so what we're going to do is we're going to look at these down here. It says sketch the following angles in standard position. It says then find a negative and positive coterminal angle to the given angle. So let's start with our sketch. We say 9 pi fourths. If I wanted to find angles coterminal to this, let's start with pi fourths. Remember, this is pi right here, and this is 2 pi right here. So we say 9 pi fourths. If we were to imagine this being split up into fourths up here, that'd be 4 pi fourths. That'd be 8 pi fourths. So 9 pi fourths, it seems to me, would be this angle right here. We say this is 9 pi fourths. So just visually, I just want to kind of talk about this visually. What would be an angle coterminal to this, one positive, one negative? I would say that couldn't we just use just a plain old pi fourths? And I think that pi fourths would be one of these coterminal angles. So we say pi fourths, is one of our coterminal angles. And we could also say, how about this angle right here, which, by the way, rotated clockwise, so it would be negative. But in terms of pi fourths, it looks like we have 7 of these pi fourths here. It would be negative 7 pi fourths, and these would be our two coterminal angles. According to what I've said over here, though, we'd say without having to actually sketch this and determine this visually, what we could do is we could actually do this algebraically. So what we're going to do is this. We're going to say 9 pi fourths. If I wanted to find something coterminal to this, what we'll do is we'll just take off 2 pi. And the important thing here is this. You're dealing with fractions. So we say this is 2 pi wholes. This would be the same thing as with the common denominator, 9 pi fourths minus 8 pi fourths. And to subtract off 8 pi fourths would give us just a single pi fourth. And you'll notice that that's our first positive coterminal angle that we were able to find here in the first place. And I'll say this, I mean, we could actually take that angle that we just got right there, pi fourths, and subtract off another 2 pi. And just to show, you know, that getting a common denominator here, we say pi fourths minus another 8 pi fourths would give us a negative 7 pi fourths, and that's of course what we confirmed visually in the first place. So with these remaining two, what I want to do here is essentially, yes, I still want to go sketch it and conceive of these, you know, make reasonable sense of it, but we say 5 pi 6, that would be, let's see, 1, 2, 3, 4, 5, 6. 5 pi 6 would be this angle right here, 5 pi 6. What I want to do is find something coterminal to this. So why don't we start with this? Let's take 5 pi 6. Let's find our negative coterminal angle first. I'm going to subtract off 2 pi, or 2 pi wholes. That'd be the same thing as 5 pi 6 minus 12 pi 6. And what we end up with here is a situation where we get a negative 7 pi 6. Now I'm going to put a box around that. I'm going to say, now go look at your picture. This is you know, visually accurate because you could see that it would take negative 6 pi 6 plus another 7 plus another pi 6 to get us to negative 7 pi 6 here. And that would land in the same spot. And again, you know, we'll take our 5 pi 6, and this time let's add 2 pi onto it, or 2 pi wholes. This would be the same thing as 5 pi 6 plus, you know, if we were to get a common denominator here, this would be 12 pi 6. And looking at this, we get, you know, as a final answer, 17 of these pi 6 things. And again, you know, that makes reasonable sense as well, because 17 pi 6, that would be counterclockwise. That would be our 12 pi 6, excuse me, plus the original 5 pi 6 that we rotated in the first place. And so that would be coterminal with that as well. And then last but not least, you know, we say negative 3 pi fourths. What if I start off with, you know, a negative angle? That's okay. You know, negative 3 pi fourths, it just means that, you know, if here's negative pi, we're rotating 3/4 of the way to that. So here's our splitting it up into fourths mentally here. And we'd say, okay, well, then it would rotate to here. Here's our negative 3 pi fourths. Negative 3 pi fourths. Okay, so if I want coterminal angles to this, again, we'll take negative 3 pi fourths. Let's do this. To find a positive coterminal angle, maybe we add on 2 pi to this. We say 2 pi over 1. That's negative 3 pi fourths plus 8 pi fourths, and that's going to give us 5 pi fourths. And again, if you were to graph this, you could see that, yes, 5 pi fourths would land right there. And again, if we said negative 3 pi fourths, take away 2 pi, take away 2 pi, or 2 pi wholes, that'd be the same thing as negative 3 pi fourths, take away 8 pi fourths, and we get negative 11 pi fourths, and this would also have to be coterminal with the original. And that makes intuitive sense here, because if we were to rotate the original negative 3 pi fourths plus another negative 8 pi fourths, which is one time around, we'd get negative 11 pi fourths. So sorry for the mess, but that's what we mean by coterminal angles, and that's how you find them in radians.